All right, y'all. In the last lesson, we talked about what an inverse matrix is, the idea of it, and why we care about them. They help us solve matrix equations. Today, what we're going to do is be given a matrix and find its inverse. And we're keeping it as short as possible with the 2x2 matrix. As a heads up, it is still a long, tedious process, but it's not too bad to understand what to do. It's just kind of annoying to actually do it, but you'll be fine. Here's where I remind you that everything is for completion, participation, effort grade, and just breathe through it and don't stress too much about it. All right. So what we have in example 1 is this innocent looking matrix. It's a 2x2, 9, -7, -5, 4. We are going to find its inverse. Now, we don't know what it is, but we know it. We know it has one, or the problem wouldn't be asking us to find it. And we know that when we multiply it by its inverse matrix, which we don't know yet, we get the identity matrix. We talked about that before. And since the original matrix is 2x2, the identity matrix is going to be 2x2. So what we need to do is figure out what goes where the question mark is. Let's see if I can move this over a bit. Maybe write it. What goes here, right? Well, whenever we don't know something in math and we have an equation about it, we put a variable there. And that's fine. So maybe I think, oh, okay, I'm going to put an x. We usually use x. But a matrix doesn't have just one x in it, right? It's got multiple entries. So we need a variable for each entry. And each variable has to be different. Because if they were all the same, it would imply that the values are all the same, but they're not. So here's what we're going to use instead of just a big old fat X inside those matrix symbols. We're going to use this, A, B, C, and D. We know it's got to be a 2x2 matrix. And so we know we need 4 variables. Right? And so this setup here is a specific example of this generic setup here. You have your original matrix with the numbers. You have your variable matrix. And when you multiply those two things together, because they're inverses, you get the identity matrix. So the question then becomes, how do we figure out what A, B, C, and D are? Well, we're going to use our matrix multiplication. For example, we know that when we multiply matrices, to figure out the value here in row 1, column 1, we multiply row 1, column 1 here. And when we multiply row by column, we multiply the first positions together. In this case, it's 9A, 9 times A, which is 9A. We multiply the second positions together, which is -7 times C, which is -7C. And that's going to equal, when you multiply those together, it equals 1, whatever's in row 1, column 1 on your answer matrix, okay? But now let's stay with the A and the C and multiply it by row 2. Row 2 by column 1. The first positions multiplied are -5 in A. The second positions are 4 times C, which is 4C. And that's going to equal the second row, first column value in the identity matrix, which is 0. And look what I have here. I have a system of two equations with two variables. We can solve that system in a few different ways. We can do elimination and substitution, or we can use matrices to solve. You're welcome to do whatever you like. I'm going to use matrix math to do it because we went through the trouble of learning it. But if you don't like it, you can just do regular old substitution or regular old elimination, okay? But here's how it looks like setting it up with matrix math. I set up my augmented matrix. And keep in mind the first column represents A and the second column represents C. And I need to get a 0 under the diagonal. So where that -5 is, I need a 0. So I am going to multiply the first row by 5 and the second row by 9, and then add them. So I'm doing 5 times row 1 plus 9 times row 2, and that will give me my new row 2. So 5 times the first row is 45, -35, and 5. And 9 times the second row is -45, 36, and 0. Adding the rows gives me 0, 1, and 5. All right, so that's my new row. So here's my new matrix. I've got row 1 did not change, so 9, -7, 1. And row 2 is now 0, 1, 5. And here we go. Remember, the last row is now already solved for, and this 1 right here represented which variable? This column was C and this column was A. So this last row means that 1C equals 5, or C equals 5. And then we can plug that back into either of the original equations to get A. So I will do the top equation, 9A minus 7C, but now I know that C is 5, equals 1. So I'm going to, that's -35, I'm going to add it to both sides. That gives me 9A equals 36. Divide by 9, A equals 4. So now I know that A equals 4 and C equals 5, which is great. What else do I need to know? I need to know B and D. So I'm going to do all this again, but for the second column in the matrix. So now we move to BD right here. I get my equations for my system by taking that second column and multiplying it by the first row. So the first positions are 9 and B, and you're multiplying those together. The second positions are -7 and D. That's row 1, column 2. Its answer is going to equal whatever is in row 1, column 2 in my identity matrix, which is 0. Now I will do row 2 times column 2. So that's -5B plus 4D equals what this time? Equals 1. Now, what do you notice about those two systems of equations? They look exactly the same. So you might be tempted to think that B and D are going to be the same as A and C, but they're not. The difference is this. That's 1, 0 there, and on this system it's 0, 1, and that's going to change your math, okay? So let's go ahead and solve for B and D. Set up your augmented matrix. 9, negative 7, 0, and negative 5, 4, 1. And we need a 0 in the same spot right here. So notice that the beginning part of the problem stays the same. 5 times row 1, 9 times row 2. This is going to give me my new row 2. So even this part stays the same, 45, negative 35. But what changes is now when I do 5 times that 0, I get 0 instead of what I got in the previous part of the problem. And then 9 times the second row is negative 45, positive 36, and positive 9. So adding vertically still gives me 0 here, still gives me 1 here, but now I've got 9. So when I write my new matrix, that constant on the bottom right is 9, and it's not 5 like it was before. But let's remember for a second, the columns in this matrix, it's no longer A and C. It's what? It's B and D, right? B and D. The first column is B, the second one is D. So when I look at this last row, which equals 9? D does, right? So D equals 9. And then we can plug it back into any of the original equations to figure out what B is. So I'll just do the first one. 9B minus 7D, D is now 9, equals 1. So that's negative 63, which go ahead and pause your video and try example 2 on your own before you watch me do it. All right, so here's example 2. We want to find the inverse of A. So we set up our variable matrix, and we know when we multiply them together, we get the 2x2 identity matrix. We are going to start by doing matrix multiplication with only the first column times each of those 2 rows. So that's 6 times A plus 5 times C, and that equals 1 from the identity matrix, because 1 is the first row, first column value. Then I'm going to switch to, so I just did this one and this. Now I will be doing this one and this. So that's the first positions are 2 and A. I multiply them. The second positions are 2 and C. And that's the second row, first column. What does that equal in the identity matrix? It equals 0. So now I'm going to solve this matrix using matrices. Remember, you can use regular substitution or regular elimination if you like. So I'm going to set up my augmented matrix here. If I multiply the second row by -3, it will cancel out this value and give me 0, which is what we want. So row 1 plus -3 times row 2 gives me my new row 2. And then, okay, so then, okay, blah, blah, blah. space. Remember, this is your A value and your C value, and this right here means that negative C equals 1, which means C equals negative 1. So this is going to hang out here for a bit. I'm going to plug that back into another of the original equations to solve for A. So that one is 6A plus 5C, where C is now negative 1, equals 1. That's negative 5. I'm going to add it to both sides. 6A equals 6. Dividing by 6, A equals 1. So I have two values now. They're just going to hang out while we go to find B and D. So now I'm switching to, I've already finished with the first column on my variable matrix. Now I'm going to this column, and I'm going to multiply it by each of these rows, and they're going to equal to these values. And this is how we're going to find B and D. So doing this row by this column, the first entries are 6 and B, so I multiply those. The second entries are 5 and D. That's first row, second column is going to equal first row, second column value here, which is 0. And then now, second row, second column, 2B plus 2D equals 1. All of this other math that I did over here, the row 1 minus 3 row 2, I can do that again. Ah, dang it. I'm trying to rush and I'm making mistakes. Okay. Not okay. Now, okay, there we go. So then my new matrix looks like this: 6, 5, 0, 0, negative 1, negative 3. That bottom row means that's D, right? This was B and D. So negative 1D equals negative 3, which means D equals positive 3. Plugging that into this equation gives me 6B plus 5 times D, which is now 3, equals 0. That's positive 15. You want to subtract it from both sides. 6B equals negative 15. Dividing both sides by 6 and simplifying by a factor of 3 gives me negative 5 over 2. So your final answer is in matrix form. A is 1, B is negative 5 halves, C is negative 1, and D is 3. You're welcome to stop the video here and go try your practice problems. I'm going to work out the last example. It works just the same as the other ones. The only difference is it's decimals. But if you want the extra practice and you want to hear me talk about it, go ahead and pause the video, try that problem, and then come back and watch me work it out. I'm going to clear all this work off so I have blank space. I'm going to go a little bit faster here. Set up my variable matrix, my identity matrix. I'm going to start with the first column. Negative 2a plus 0.4c equals 1. 1a plus 0.8c equals 0. My augmented matrix looks like this. I'm going to do 2 times the second row. That gives me 0, 2, and 1 when I add here. I'm not going to be rewriting all my matrices over and over again during the process. I'm just going to right here say that this means, because this is our A and our C, so this bottom row here means 2C equals 1, so C equals 1/2. I will take that and plug it into this equation, which will give me negative 2a plus 0.4 times c, which is now 1/2, equals 1. So negative 2a, half of 0.4 is 0.2. I will subtract that from both sides. Negative 2a equals negative 1.2. Divide by negative 2. A equals positive 0.6. I can't read my own handwriting. And I'm trying to rush because I know the video is long. That's negative. So minus 0.2. I'm going to get caught up here in just a second. So 1 minus 0.2 is 0.8. And half of 0.8 and negative is negative 0.4. My apologies. So this is just going to hang out here. I've got A and C. Let's go back up and get B and D. Instead of going through all that trouble of matrix multiplication again, we already know it's going to look just like this, only with B and D, where A and C are. And instead of 1, 0, it's going to be 0, 1. And we know that we're still going to do the same row operations. So I'm going to do I'm still going to do 2 times the second row here and add it to the first one. There's 2 times everything. Add them gives me 0, 2, and 2. So in this row right here, remember the columns are B and D. So this right here is giving me 2d equals 2. So d equals 1. And then I plug that into this equation and get negative 2b plus 0.4 times d, which is 1, equals 0. Subtract the 0.4 from both sides and divide by negative 2. That's a 0, not a 6. And b equals positive 0.2. So my final answer is the inverse matrix of G is A negative 0.4, B is 0.2, C is 1/2 or 0.5, and D is 1. And you have completed your matrix unit. Go work your practice problems and upload it to Google Classroom. Next week, we will be doing new material.